first topic is rate of reactions, graphs, and factor affecting reaction rate. This is a guaranteed question in your exam. You should know how to draw a graph when the rate changes. Remember, when you draw the new graph or the new line will be steeper if the rate increases, will be less steep if the rate decreases, and the flat part of the graph, which reflects the highest concentration of the product, this is going to be at a higher value if the concentration of the reactant increased. But if any other factors have increased the rate other than the concentration of the reactant, like the use of a catalyst or the increase in the surface area to volume ratio, then in this case, the final concentration of the product will be exactly the same, which means the line will flatten at the same highest value for the concentration of the product. You need to know how to calculate rate of the reaction from the graph. They will either ask you to calculate the average or the mean rate for the reaction, or they could give you the tangent at a certain point and ask you to calculate the rate at that specific time or at that specific point. The different factors affecting the rate with explanation. So the temperature, so increase in temperature increases the rate, concentration of the solution will increase the rate, the pressure only in case of gases, and the surface area to volume ratio, and also the use of the catalyst. You should be able to use the collision theory to explain why these factors would increase the rate for the reaction. Topic 2, reversible reaction and position of equilibrium. This is also a very common question in the exam, and it's almost a certain question in your exam. So you should know what is meant by equilibrium, when equilibrium is reached for reversible reactions, and the different factors affecting the position of equilibrium. So temperature, which direction of the reaction would be exothermic. Normally they will mention that in the question. So they will tell you that the forward reaction is exothermic or the forward reaction is endothermic. So you can judge whether increasing temperature would increase the rate of the forward or increase the rate of the reverse reaction. The concentration, which is only for solutions, and then the pressure, which only affects the rate of the reaction if there are gases. Remember that the use of catalyst will not affect the position of equilibrium. Remember also for pressure in case of gases, if the number of moles of gases for the reactant and product is exactly the same, then there will be no effect of pressure on the rate of forward or backward reaction. So there will be no effect on the position of equilibrium. Mostly they will give you a gaseous reaction, and the most common reaction that comes in the exam is the reaction between nitrogen and hydrogen to give you ammonia. Topic 3 is organic chemistry, and for your specification, you only need to know hydrocarbon. So mostly they will ask you to write a balanced equation for complete or incomplete combustion, and they probably going to ask you about the general formula for alkanes, which is CnH2n plus 2. It's almost certain in each and every exam, they ask you to name one of the first four members of alkane, so you should familiarize yourself with naming the first four members of the alkanes. The boiling point and viscosity of alkanes and how they increase with the increase in the size of the alkane, fractional distillation of crude oils, and the formation of crude oil. It's very common to ask you how crude oils are formed. And then cracking, they might ask you to complete an equation for cracking and why cracking of long chain hydrocarbon is needed. And finally, if they ask you about cracking, because one of the products of cracking is alkene, which has double bond, then they will definitely ask you for the test for the double bond, which is the bromine water test. Topic 4, chemical analysis. So pure substance and formulation, and you should know that you can judge whether a substance is pure or not by measuring its melting point or boiling point. Chemical test for gases. Carbon dioxide is the most common gas that comes in the exam. However, that doesn't mean that test for hydrogen, oxygen, or chlorine will not come. Any of these would come. So you should revise all chemical tests for gases. Paper chromatography is very common in your exam, and you should know how to plan an experiment using paper chromatography because this is a very common exam question. Topic 5, gases in the atmosphere. So carbon footprint is one of the most common topics that come in the exam when we talk about the gases in the atmosphere. You should know the sources of carbon footprint in the life cycle of the product, and don't forget that the sources of the carbon footprint doesn't only come from the use of the product, but also when we talk about the extraction of the raw material that is used, the transportation of the raw material, the production process itself, like the use of fossil fuel during the operation of the machinery, for example, the use of the product, and finally the disposal. So there are so many stages where the carbon footprint can be calculated for the production or for the life cycle of any product. And then how to reduce the carbon footprint and why there are limited measures. The sources of greenhouse gases on Earth, carbon dioxide and methane, and the effect of greenhouse gases on the average Earth temperature. Also, atmospheric pollutants from fuel and how to reduce nitrogen oxides emission from cars. Finally, the changes in the different gases on Earth over the time. You should know how carbon dioxide concentration decreased over time, and then how oxygen increased, how nitrogen increased as well. The last topic is using resources. You should be able to define finite resource and renewable resources. The extraction of copper from low-grade ores is a very common question, and usually they ask you either about phytomining or bioleaching. And then potable water, very common as well for both freshwater and salty water. You should know how to get potable water from both freshwater and salty water. And